presentation. I hope everyone can see my screen.
especially خلي جوه الفايدة يعني.
Yes, sir.
Okay, this case study is mainly related to the collision of a vessel MV Aviator and MV Atlantic Grace. This collision happened on November 26th last year. Okay, and this was in the Gulf of Kutch. And this vessel was supposed to come in ASRY, but they are still working on the temporary repair of the vessel to bring her to the shipyard. I will share some of the pictures of this vessel. Actually, what happened is MV Atlantic, she came and directly collided with MV Aviator in the midship area. MV Aviator is a bulk carrier and it has got a severe damage in this midship area. You can see in this picture, the bulbous bow of Grace has pierced through the cargo hold. This is the cargo hold. And this is a very extensive damage. The MV Aviator vessel is still struggling in India. She is in Bengal, West Bengal, doing this temporary repair for vessel towing. So this repair has been going on since December.
Excuse me, letter. Yes.
This is what has happened. This is MV Aviator, a bulk carrier.
Rajat, the screen is fixed on the cover.
Can you see now?
Yes, we can see the cover only, Rajat.
Only cover. Just a moment.
One minute, Rajat. Now check, Rajat. I give you the control. Ah, yes. Now it's moving.
Yes.
Rajat. Okay.
Now moving. Okay. I will open the pictures again. Can you see?
Yes.
Yes, Rajat, it is moving now. Yes.
Yeah. This is what has happened there. This is MV Aviator and this is MV Atlantic. So she directly collided at the midship section on the port side of this vessel. See, this is the one. Now this is cargo hold number 3, somewhere in the midship. And this is really a severe damage for this vessel. Even this vessel particular bulbous bow is severely damaged. This is the bow deck area, all the bulwarks, tensions,
Rajat,
everything.
also the
Now,
screen is not moving, Rajat. Why you cannot control, Rajat?
okay, now you can see.
Yes, now can see.
Okay, now. Okay, these are some of the pictures of this damage. Okay, now usually what happens whenever we have an accident ship, first thing will come in picture is insurance. So the insurance parties and the class, they will have an inspection. And with the diving team, since the area is immersed here, a diving team will be deployed, which will be taking underwater videos, pictures of the structure damaged, and they will come up with a damage report. And this damage report will be reviewed between the diving team, the insurance agency, and the class which this ship belongs to. So once that this is finalized, this will be reviewed with, of course, with the owner. So this report is submitted to the shipyard, who is going to do this repair. In this case, the biggest challenge for us was the diving report was the details provided was very slim. I will show you the diving report also, what we. Can you see? Ahmed, can you see the screen?
Slide
No,
number
Rajat,
3
still
or
we are talking about the ship. Still we have the picture of the damage. Rajat.
Oh,
I believe you have to minimize it, then you open the other one.
yeah, I did that just now. Okay, one second, I'll see. Okay. Okay, I will. Second, I will go back again and. Okay.
Here, Rajat, we are on the back on the page content now.
For this particular vessel, we had done some homework from our side since the details which were provided by the damage control team were very slim. So in order to get our fabrications drawing prepared, we collected the data from client, all the required drawings uh, from the client like general arrangement, then structural previous drawing, midship sections, transverse section, longitudinal, deck plans, then shell expansion, scantling drawing. All these drawings were collected from the client and based on the
excuse me,
damage
Mr.
area.
Rashad. The screen is fixed at the first slide.
Yeah. Now can you see?
Now,
Now,
now
Yes, Rajat.
second slide.
yes. So I will go through the contents in this presentation now. See the contents which we have is damage picture and then our build strategy. What was our plan to do with this vessel? Okay, these are the pictures of the damage areas. And these were the strategies which we were planning. One was the block strategy. Since the damage was severe, it was around 250 tons estimated and can increase because the details were not that clear. So there were chances that this damage areas can be extended. So there are three things in which we can carry out this repair. One is block building. Second is combination of block and panels. And third one can be panels. I will go through this now. For block building, this is actually a much better way of carrying out any repair. Since most of the job prefabrication will be done in the workshop. where and always workshop is the convenient place to get all these panels assembled and is the fast way. Actually, all the resources are available. Then you can work very easily. No concerns, no all the lifting and infrastructure required is available in the workshop and can be done very fast. So, but with the block building, we have got limitations also with the craneage. The craneage available in the yard, how much ton maximum tonnage of block you can build, and how you can transport it. So all these factors will come in the picture. And also in this case, block building was a tough challenge because if you see the damage is in the midship section. So if suppose for the block building, you need to cut the particular section to get this block in place. So now if you cut this area, then the vessel will be exposed for further deformation since you are going to cut the strength member. Right now, the vessel actually the load was on this particular area. She is the one carrying the load of the vessel on the port side to avoid any deformation of the vessel. And there were chances, suppose if we start cutting this portion, then vessel can deform. Then if it moves from her center line, then it's very tough to bring her back. So we decided to go panel wise for this vessel. This vessel is supposed to come in ASRY for 48 days. So we had divided her in two parts, three sections basically. First is in afloat condition at the berth. So whatever the areas above water level, we had made a plan to go panel by panel, side shell panel, main deck panel. I will come to that in the further slides with all the sequence. Okay, okay. Can you see this?
One minute, Rajat, please. Can you go back one slide? No, the options. Yes, I just want to ask here, what is the difference between the block and the panels? Anybody can answer us?
Panel is just a plate with stiffeners, but block is a complete compartment.
Yes, correct. Yeah. The panel is suppose a block, a vessel is made of different levels. Okay, side shell, inner shell, main deck, intermediate decks, bottom plates, and internal all stiffening. In that particular area, getting all this in one unit is a block, and each block is made up of separate units. Like side shell with her stiffeners is a panel. Correct what you said. So since we don't have this luxury on this particular vessel, so in order to control the damage, we had made this sequence. Can you see the screen?
Yes.
Yeah. So the sequence is, in the sequence one, we had afloat condition wherein the vessel, the lightweight draft of this vessel is up to 3 meters. Okay, so we had an opportunity, anything which comes above 3 meters, 3.5. We were planning to do this in the offload condition. That was our phase one. So we had the plan to prepare the shell panels based on all the details we received from the client. Then this particular section was having TST slope plate. I will show you the drawing what is exactly the slope plate is. Then the frames, internal strength member, TST frames. These are the primary strength member. Every structure will be having primary strength member and secondary strength member. These are called the web frames, TST frames. And secondary strength members are your intermediate flat bar, some of the brackets, some other additional stiffening, carling in way of the combing. These all are called secondary strength members. So in sequence 1 above waterline, we are planning to install the shell panel first. So these are the shell panels which were supposed to be cropped and taken in place. Once these panels goes in place, the second one was to be TST slope plate. We cannot jumble this because everything have to go in a sequence, what is mentioned here. So first the shell plates will go 3, then the cropping of this particular plate, then this will follow all the sloping plates. After the sloping plates, their frame should come in position. After frame, the deck plate. So this was our sequence, phase 1 in afloat. Sequence 2. Now once this is everything is aligned, taken in place, we have to weld this area so that everything is confirmed that welded out and it can take the required loading. Then the sequence 2 was TST slope plates for this particular further section, next section of the block. And same thing it is, shell plate, slope plate, frames and deck panels. The sequence 3 is third block. Maybe I will go to the next slide here. Okay, this is what I was talking about. This is in the sequence 1, afloat condition. This is in sequence 2, afloat condition. And this is in sequence 3, afloat condition. For this particular section, there will be shell plate.
Your mouse is not pointing. Yes, Raja, this is good.
Yeah, now it's okay. Let me see the panel drawing. Just a second. Okay. Now in the previous slide, I have mentioned here sequence 1. Okay. This particular sequence is having 4 different types of panels. Sequence 2 also same, 4 different types of panels here. So I will go to the panel 1 first. So now our water line was somewhere here. Can you see the mouse?
Yes, Raja.
Yeah.
Yes.
So this is where the water line of the vessel is, the one which is highlighted here. OK, so our initial plan was to do this for certain period of time before she goes in the dry dock. So this is our first panel. This will be having side shell plate, which will go first. Then the slope plate. I will show you the slope plate now. OK, now suppose this is the frame, TST frame, what I was talking about. The plate which is coming here, this is called a slope plate. OK, so as a sequence, first side shell will go along with her stiffeners. Then the slope plate will be fitted and top of it, the frames will be fitted. This particular frame, this is called web frame, TST frame. And then the main deck will come in place. So this together, once it is confirmed, everything is fitted, water leveled, aligned. And then we can say that this particular block is ready. So we have to weld this out. Then we can go to the second section. So second section will follow the same thing. Same sequence will follow. And also for the third section. So this is our afloat condition. Once we are done with this particular area, what we are left is with this bottom, and this is underwater. We can do this only once we dock the vessel. So this phase 1, sequence 2, sequence 3, all 3 sequences are done over here. So we had made our drawings also, for which we have the component numbers also here and tonnage of these areas. Now the sequence 4 will be during docking. So now this sequence 4 is this area. This will be having a portion of side shell, the bilge plate, the curved plate where the bilge kill sits, and the bottom panel. Go to that. Okay. Okay, this is the bilge frame. The plate which comes here in this area is called a bilge plate. And the bottom will come in this area. Above this will be our side shell. Okay, now these areas, once these are done, will be going to the dock to carry out the underwater area repair. So for this underwater, we don't have any information. What is the condition? At least the topside areas, we can have a look, and any changes required, anything, any modifications to be done to the drawing what we prepared initially, we can do the required changes. But for the bottom, we are not aware up to what extent is the damage. So normally what we do is once the vessel comes here, we are having our own diving team. So what we do, the damage report which we receive from client, we take this report, discuss with our diving team, and they go and verify the underwater areas. At least try to get some additional information from what the client have provided us. So upon those details from yard side, we compare both the reports, client and the yard report. If anything additional, we raise the alarm. We inform the client that so and so areas are additional, or there is damage extended or reduced. So after that, we will take a call. So the third, once before entering the dock, see, if we don't have material prepared, nothing done, then there's no point of going in the dock, because always dock is the area where we cannot play with the time. Even few hours also it is very difficult. There is a set time in our shipyard. There is a set time for any vessel to dock and undock, and there is no margin for error. So if we get delayed, this will affect the shipyard, other vessels coming in the shipyard also. So we have to be very precise on docking and undocking of a ship. So we have to prepare ourselves well in advance before getting the vessel in the dock. So in this case, our plan was, since the vessel will be here for this initial period of time alongside. So this was around 26 days. So we were in a position to do our underdiving survey, verify both the reports, yard and client, then prepare a drawing for all the areas which are renewal is required, and fabricate the panels or a block depending on the capacity, and keep it ready before the vessel goes inside the dock. So this will enable us to reduce the docking period in the time duration in the dock, and we can come out with full-fledged of this works done in the dock, and then what will remain is the upper areas, whatever required. So what we had done is we had prepared our drawings for double bottom areas. Okay, and our plan was to keep this block or panel fabricated and ready before the vessel arrives in the dock. So this was our plan. I will show some of the drawings. Okay. This was our sequence 4, that is underwater area. So we had our side shell panel. This is our side shell panel, which was under portion, which was under the water line. Then the bilge floor, then the frame, bottom frame, which was having damage up to 2.2 meters. Then bilge plate. This is the curved and this is exploded view of the bilge plate. Okay, then the bottom plate. So we were planning to have this all fabricated, and if time permits, we were having a plan B to get this assembled as a single unit and keep it ready for the vessel upon docking to install it on board. So we were having 2-3 plans in this regards with this particular vessel. And we had made our master schedule. This is our Yama.
Ashraf is saying that the slider freeze. No, Ashraf, it is moving. I can see it moving.
I will out and enter again. Okay. Sorry.
Okay, sorry, Rajat.
It's working now. Thank you.
So these are some of the drawings what we prepared. Bilge, bottom, frames, everything prefabricate, and if we further have time, then we would have gone for plan B, that assemble it as a single unit and take it in place. This would have saved us a further time. So what happens is once this underwater area damage repair is done, you have to go for treatment since you are in the dock. Later on, once vessel is undocked, you don't have any access to these areas. So upon steel renewal, we have to ensure that this vessel is watertight. So we have to go for the testing. There are different types of tests for the weld and all the NDT, UT, MPI, vacuum. Then for the tanks, we have to go for the air test. Once that part is done, go for the tank treatment, go for the shell treatment. So all these jobs are to be done in the dock itself before we get the vessel out. So once this all part is done, we take the vessel out and there will be the superstructure areas, means the top areas which needs like bulwark. See, these are the above areas. Can you see the cursor? This is hedge combing.
Yes.
Yeah, this is the hedge combing. These are your bulwark areas, stanchions. Okay, this we can do in phase number 3 in the offload condition, because now we are in a good shape that when she comes alongside, we can work on these items. I will like to emphasize on one of the item here. This is the hedge cover, and this is all some of the hedge covers are weather tight, some are watertight. So this combing needs a precise alignment. So we have to be very, very cautious when we make the alignment and fitting of this combing. So this hedge cover will sit on the combing and your sealant water tightness member will be here rubber. So if any deflection on this combing will affect in the gap and we will have water leakage. So for any this cargo and all, it's not allowed to have any leakages to have from this area. Otherwise, your cargo will get spoiled. So this is very important and we have to take very extra care in this. So now still we are waiting for this vessel to come in the yard. Our plan is to start with the fabrication, but due to some reasons, client didn't manage to get hold of this damage, because to get this vessel towed to our shipyard, class had asked for at least a temporary damage repair so that she is acceptable to get towed to ASRY. But still they are working on this. Since you can see here, there's a lot of water ingress in the cargo hold. And
Mr.
it's like
just a question, please.
Yeah.
Regarding this top area, this installation also done alongside?
You mean to say this combing
Yes.
and the tensions? Yeah, this we
Yeah.
can do alongside. Yes.
So this easily alongside this, no problem. In the facilities is okay for this one.
Yes, yes, we can do all these things. We'll be working on the shell areas alongside. So in the fourth level, we will come here and install this. We are having cranes with us.
Rajat, because
Yeah,
Mahmoud is
Mahmoud?
asking a question. Let me ask Mahmoud another question. Mahmoud, if this, as Rajat mentioning here, this hatch combing area is a very sensitive part when it comes to the alignment for the hatch cover, right?
Yes.
So the question is, what is your reference?
Drawing?
No, drawing is not reference. Drawing is a theoretical part. Drawing we studied only in college. When it comes to reality, the ship is already aged, as you can see. So the question is, what is your reference when you make this alignment?
Okay, because I have damage also in the bottom. It's not easy to be clear of this alignment, correct? So
So what is the reference?
actual. So the actual measurement.
Okay, you will measure it, but it is damaged already. So now you need to think about reference. Sometimes there are jobs you cannot do it, even if it is above water line. Sometimes you cannot do it because you are looking for the keel, the bottom keel, to be a reference for you. This is not the
Okay.
case, but I'm asking you, what is the reference that you will take it to make sure that this alignment of the hatch combing? Not only you, yani, anybody else can have an idea.
Okay,
Let us
think
throw
of
it.
this one.
Sorry?
Let me think in this one.
Okay, think and other to think also. I need
Yeah,
other
okay.
participant to get an answer here.
Yes, okay.
What I'll do is to elaborate on this, I will open one of the hedge cover drawing. Let me go through it. Okay, can you see this?
Yes, sir.
Yeah. Okay, now this is one of your cargo hold, for example.
Okay.
Okay. Since the vessel, I will 1 second. One second now. So the okay, now for this particular vessel, the damage is here. Okay.
This is top view, huh, for everybody.
Top view of the hedge cover. Huh? See, this is your particular cargo hold. Okay, the other vessel came and hit bang here. So now this is fully deformed. Now to get this back in place, you need a reference point.
Yes.
Yes. So from where you will get this reference point? See. So now our reference point lies on this particular case somewhere here and somewhere here. But we were not that sure whether this damage is extended only in the center area. We were thinking our plan was to bring it from these two round circles. This was our reference. And we were supposed to put our reference line, piano wires from top side, from the side, and put a piano wire, and this would have been our reference to get this combing repaired. So being this as the reference, there will be one resting bar for this rubber, like a sealant. Okay. So this reference we would have taken this dimension and fitted this particular combing here. Suppose in case if this is also damaged, so what will be our next step? We would have gone to the next combing level. Let me see if I have the full cargo hold drawing. Yes, okay. Now the
Rajat,
actually
you are trying to give them an answer more easy. I'm trying to make it more difficult. You are friendly, Rajat. I'm not friendly
okay.
with you. So what I'm trying to let them think about it. Mahmoud, still I'm waiting for you. I want you to tell me the reference.
Okay, I'm almost got it, but
Because Rajat is Alibaba. I know Rajat is Alibaba. Tell me, Mahmoud.
he got the answer on the screen.
يلا يا محمود, tell us.
okay. Now the first step, as Mr. Jad said, we can get this measurement from the actual measurement from the 2 points of this hatch, correct?
They are buckled already. Cannot take it as a
okay.
reference.
Okay, but the problem now, if we have also deflection in these 2 points, which is make it more difficult to get this measurement. So we can get this from the keel, as you say.
No, you cannot take it from the keel.
We cannot.
Now you are coming as Rajat said. The first
From the-
sequence needs float repair. Yes, doctor. Sorry, doctor.
we can take the reference from 2 point from the coming of the adjacent hatch cover
Yes.
at the extent of the same coming.
You can come
Yes.
somewhere here.
Yes.
Can come somewhere here.
Yes. Yes.
And to cross check this, you can see here also whether this is everything in line or not.
Mahmoud, now Rajat
Yes.
is not academy. So you cannot tell him Dr. Rajat, then he will tell you a good answer. Dr. Mustafa gives the right answer. This is what I want to tell you. You have to always to think about the adjacent boundaries for you, as Rajat mark it now.
Yes.
Okay, got it.
And in this case, you have to be double, triple sure. So after this, even once you get this as a reference, go to your center line. Take the measurement from center line also. This will be your third confirming point. So from center line, you measure this. How much is the distance? How much is the distance? And whatever you repair, how much will be that? Because center line of the ship always remains the same. So this will be your third reference. Try to bring in more and more parameters which will confirm that your repair is up to the mark.
Okay.
Rajat, you can open to us the diving report. I can see it.
Yeah. Yes. I will open the diving report now.
Unless you are upset from Mahmoud and you don't want to share it.
Damage report.
Yes.
Can you see, Ahmed?
Yes.
Yeah.
Yes.
Yes.
Yeah. Okay. This is the damage report we got from the owners before the vessel arrival.
Can you go up, Rajat, from there?
Yeah.
Gentlemen, here I would like to highlight the client name. No, 1 minute. This is Smith Salvage. This is one of the biggest company in salvage in the worldwide. Smith Salvage. This is one of the jobs that the marine engineer can go to work on it afterwards. To work on the salvage. LR, the Lloyds, they have a separate unit for a salvage, only for salvage ships. As I said, Smith is one of the biggest one, but also LR, Lloyds, these big class societies, they have their separate unit for the salvage. So this is one of the very important thing. And what more important is how to write this report, because this report will be the reference for the insurance to see, yes, we can pay or we will not pay. Who is the mistaken or not the mistaken? So this kind of salvage and the incident report that we are seeing is totally different. Is one of the things that you have to Maybe you can work only all your life in the accident and make incident report, make salvage report like this. So this is one of the good things that is very important for us. And unfortunately, I don't see much trying to catch this career yet. Even for the RINA, the Royal Institute of Naval Architecture of UK, they have a separate conference every year called only damage ship. And this damage ship only talking about how we can improve in order to avoid the damage, or how the salvage company, came in picture in order to make salvage for the ships that got damaged. So this is really an interesting topic. I hope one day I can see one of these good students working on this field. Yeah. Sorry, Rajat, for interrupting. Okay, Rajat, go ahead.
These are the details of the vessel. Okay.
This is the collusion.
This is the ship we are waiting for since last 2 months. Me and Hamad eagerly waiting for this ship to come in the yard.
Yes, of course.
Yeah, this is the one. You see.
One more thing I would like to highlight here. Sorry, Rajat. When you, inshallah, when everybody of you go for to be an engineer working in the field, the most important thing to know is to establish your database. So you have to have a separate folder for each project you are working. Even if you are working on board like Mahmoud, you have to have this kind of every ship you went on board to have a separate folder for it. When you have a separate folder, you are collecting all the information related to this project. Then you are taking pictures and keeping it in this folder for reference. Reference means reference for your future. So if you need it, you will take it. And then you can find it easily whenever you search. The most important thing when you take a picture is how you are taking it, which angle you are taking it, and what you want to say from this picture. This is clearly shown in any magazine, in any scientific magazine you read, that you will find every picture in the advertising is not an advertising as much as it is want to show how much the picture itself want to talk to tell you what is the content of it. Like exactly what we are doing when we see McDonald's when he advertising for the burger. So I want to tell you how much the burger is thick, how much the ketchup is spicy, how much all this. Same here. If you can see the picture in front of us, you can see how the guy who took the picture is not only taking a picture, he want to tell you how much is enter from one ship to another, the collusion. The collusion happened in which level? What is the effect of the cranes? There are a lot of things the picture want to tell you. So you have to, this is the same for you. Whenever you take a picture, please remember, let your picture talk on behalf of you. Let your picture remind you what you saw at that day and why you captured this picture. This is very, very important, because whenever you write a report, even whenever you will put a picture, the picture will be more faster to the top management to see more than reading all your paper, even if it is 5 to 10 pages. Your picture will tell the top management, are you really an engineer taking a picture, or you are just a guy saw something, took picture for it. So I'm not telling about you're supposed to be photographic, you're supposed to learn the picture science. This is not my reference. My main talk is, as an engineer, think when you capture a picture, what your picture want to say. What your picture will tell you if you want to open it again and remember it again. See, all Rajat, the report that he did, and the building strategy or the repair strategy, which thankful he did an excellent job for it, frankly. And all he did only looking to the picture. The writing, if you see the report in detail, you will find the writing is only explaining what happened at that day. But only the thing that Rajat built all his strategy, even when we talk about the reference point between the hatch combing and the hatch cover, and from one adjacent to another, only based on the picture. So as we learned from our good doctors from university, that your engineering drawings which talks, and I'm from practical side, I'm telling you also your picture will talk. So please be very careful when you take a picture, and you have to make sure you put it in the folder of your project for your future reference. Sorry, Rajat, for taking time.
Thank you, Mr. Ahmed.
This is how the bulbous bow has entered the cargo hold. You can see the condition of, and you can see here this area, we can see the combing has been damaged.
Yes.
So this is the area which I was talking about before.
Yes, yes, I got it.
Sorry, Ahmed, I was at home actually. I was not expecting this presentation.
I like the voice of your son more than your voice. Let him cry and play. He's making good background.
Okay, these were the details given by the diving team. Okay, and one report. This is what we have, showing some extent here. 3.5 meter to the bottom. And this is what they had given. And from there, this we had derived our drawings, our build strategy. So that's all. This is the one. So now we are waiting for this vessel to come. Hopefully one day she come here in ASRY, and we are eagerly waiting to get this vessel back in operation.
I want to know, Rajat, finish or still you have something else?
Yeah, I'm done now, almost done. I will stop sharing. Okay. Yeah, yeah.
I would like to show you something else, gentlemen and ladies. 1 minute. Can see my screen?
No, still black.
No.
Cannot see my screen. Now?
Now, yes.
Yeah, now clear. Yeah.
Here, another example I would like to share it with you, which is very interesting one. This is a barge, a normal barge. It's not as it is biplane barge, frankly. But let us say it is a barge that's coming in the dock. As you can see down, this is the if you can see this line is the block arrangement. You can see my mouse, right?
Yes.
Yes.
So this is the block arrangement from, and this is the frames, of course, as you can see, from 50 to 130. The interesting here that I would like to share it with you all, that this barge having a big bottom repair. As you can see, all this green, black, blue, green, red, all this is a block repair, is a bottom repair, sorry. in order to make this bottom repair happening, we have to have a sequence for the repair. See, even for the bottom repair, I cannot cut one plate from here to here and that's it. I have to have a sequence. So as you can see in the screen, there is sequence 1, related sequence 1, then sequence 2, then sequence 3, sequence 2 also, sequence 2, and it's going on. And then when you make close down for sequence 1, you will find it like this. See, you can find that sequence 1 itself have portions 1.2, 1.1, 1.4, 1.3. Why is that? Because whenever I am start working in a let us say, for example, in this sequence 1.1, these blocks, I have to take it and put the pink blocks in place to avoid any buckling on the bottom. So here, the idea that I want to explain it to everybody, when it comes even for a pair of a bottom, you have to always to think about how the stresses will come, when the stresses, how to avoid it, by when putting the blocks, where to put it, which blocks you are going to remove, then in order to have the repair. Of course, this repair, the area that need to repair was mentioned by the UT people, the thick thickness gauging people. When they make thickness, they found that it is beyond the class requirement, 25% less than the original thickness of the plate. So this is why they define that this area need a repair. When they give us this area and this area and that area and that area, then we start putting the sequence, which one will start first, which one will go after. So imagine even for this small thing, we have to have a sequence. Not only I'm talking about the welding sequence in each plate of these, I'm talking about a sequence, a repair for location by location, how you are going to do it. So you can allow block removals and block entering, block removals and block entering. So in order to finish all this part. Do you understand my point, or shall I explain it in another way?
Yes, it's clear.
Yes, got it. Yeah. Yes.
So here is the same, Mahmoud, the same topic that we are talking. Here when it comes, they will always be afraid about the alignment, about to avoid any buckling, to avoid all this. So they are taking the keel as a reference.
Okay.
Because it is not about only the main engine. When you are working on the shaft or the gearbox or whatever, you want to look where is the reference. Also, when you work on the steel, especially in such a sensitive part with a sequence like this, you have to think about the sequence. You have to think about your reference. Then from your reference, you will know how you will do the job. Okay.
Okay.
Then the thing will come back to you, which welding methodology you will do, either CO2 welding or normal welding or whatever. All this have to come in place so you can plan your full repair, how you're going to do it. Okay.
Okay.
Another thing I would like to highlight. Rajat, can you open the presentation? Sorry. Rajat? Yes, please. Here, when it comes here in the here, this one, when we have these three options of the strategy of repair, when it comes to if you talk about cost as a manpower cost of your people that are going to work, for sure you will prefer to have block building strategy. You will not go for the panels because the panels will kill you by the man hours.
Mm-hmm.
But when it comes, it's better for you to have block. And it is less painful for you to go for combination. But the most painful as a man hour wise for your manpower, it will go for panel. So the question here will come now, which dock I'm going? If I am going to big dock, okay, I will do it as a block. Mm-hmm. If I am going to a very congested dock where there is no space aside, then I have to do panels. If I am going to a medium one, okay, I can go for the combination. Then I have to see if I have enough manpower or I don't have enough manpower. Maybe I don't have enough manpower. So if I use the painful one, the panel one, I will be, sorry to say, screwed by not having enough manpower. Or if I go with the block one, I will minimize the manpower, which will save my manpower to work in another location or another ship. So all these parameters have to come on the plane, to have to come when you are thinking which strategy will work, either block or combination or panel. Your manpower, the dock that you are going to, your plates are ready or not ready, which sequence you will follow as Rajat explained. All these kind of things you have to very, very careful about it. Because it is not only to say, okay, the easiest the block, and we will make a block. Yes, the block is easy. But when it comes to manpower, the painful will be panel. So we choose the painful one because we are going to a tight dock. Very limited time frame. This is why we had to go for the painful option. So these all parameters, this is where the project manager will come and start thinking about the repair strategy and the resources and how we can plan and how we can choose and how we can convince the top management that this is the option that I have to go for, not this option that I have to go for. However, it is when it comes theoretical by the book, block, but when it comes to reality, it is the panel. Okay, so maybe you don't have a crane to lift this block. And if you see this picture, the valuable information, sorry, not this one, the valuable information in this part, as Rajat said, the sequence, and he's explained everybody, but also the weight part here is very crucial for us because the weight will tell you that this sequence, how much tonnage will be total. So can your crane facility can lift it or not? Maybe you don't have a crane facility to lift it. So this also will come in the game. This is why he put the weight here. So he can always have understanding that the yard facilities can take it or not. This is part of his resource planning. Maybe, okay, maybe we are going to big dock. Maybe we can make a block option, the block option, but the crane dock cannot lift it.
And that was my question. Also, these facilities is okay for the top area to assemble the top area alongside or not? This was my question.
Exactly. Well, this is what I'm trying to tell Mahmoud. That all of these things, this is why it comes to the project management, the resources, the manpower, the cost, how he will plan, the repair strategy. The repair strategy come to the game that that today I am raising in the group. Which methodology in the project management we are going? Everybody saying it is water flow, but when it comes to a reality, you have to think which project and which era you are working, pandemic era or normal era. The superintendent or the client representative can go to make normal inspection, or he relies only on the ship's crew to make the inspection and send him the report. So all of these parameters you have to consider, because this is part of your stakeholder management. This is part of your thinking, how you are planning, how you are putting all these things in a mind mapping, brainstorming with your team before you release this. Rajat, by the way, released this presentation to the top management, to the top management, MD himself, to explain to him how he will repair this project. So in order for the MD to be convinced, Rajat needs to show all the parameters from this part to this sequence. Even the MD, if he's not technical guy, there are engineers, there are technical managers are sitting beside him, will advise him if this guy is saying right or saying bullshit. And all this sequence, as you can see, this all comes one by one, place by place, panel by panel. Not only by Rajat only, by Rajat and the steel supervisor and the steel team sit beside him, painting team sit beside him. All of them put their effort to make this big plan. So we can tell that this is the breakdown, this is the critical passes by red, this is our project. And this is our, if you can see here, this is our sequence, which sequence, how duration, which sequence will take. Then you can see here which this is what, Rajat? This is equipment part. I believe line by line. Then you can see here that when it comes to inspection and test planning, then when it comes here, the full plan, trade-wise, all of things he studied in order to maintain the project cost, project delivery, project everything. Any question?
No, it's clear. Thank you very much.
شباب.
Thank you, Mr. Ahmed. بصراحة you discussed everything.
Can we ask Mr. Dr. Mustafa, sorry?
Thank you, Mr. Ahmed. شكرا.
Shall we play with the student and ask any one of them or no need?
Thank you, Inja Ahmed. Thank you.
Yes. Thank you, Rajat, for your time and effort, and for the short notice, for joining in place of Mustafa. Appreciate it and thank you very much. Thank you all.
Thank you everyone for joining. So Ahmed, looks like the next presentation will be given by Mustafa regarding the offshore.
You are very unique project management for us, and you are working on the ship repair and the offshore. And you are one of my jokers in the yard, so I cannot rely to anybody else to give the rig repair except you. So you are going to make this presentation, the rig repair, and I am waiting for it myself.
Okay. Okay,
and with your lovely sound of your son.
Yeah, he's eagerly waiting now.
Okay. Thank you all. شكرا يا دكتور. تسلم. Thank you.
Thank you everyone. Thanks for your time.